This is SpaceTime Series 25, Episode 116. Coming up on SpaceTime, NASA's Dragon helicopter mission to the distant world of Titan. Crunch time for NASA's Perseverance rover's search for life on the red planet Mars. And parts of the Northern Hemisphere experience a spectacular partial solar eclipse. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's undertaken a major survey of the Saturnian moon Titan's Selk crater region, which will be one of the primary targets of the Dragonfly helicopter mission in 2034. The 450-kilogram Dragonfly will be a larger successor to the 1.8-kilogram Mars Ingenuity rotocopter, which has been exploring the Jezero crater region of the Red Planet since arriving there in February 2021 aboard the Mars Perseverance rover. Dragonfly will initially land in dunes to the southeast of the Selk impact structure, at the edge of a dark region called Shangri-La. It'll explore this region in a series of flights up to 8 kilometers long each and acquire samples from selected areas with interesting geography. After landing on Titan, it'll travel to the Selk impact crater, where in addition to organic compounds, there's also evidence of past liquid water. The Selk crater is a geologically young impact structure, some 90 kilometers in diameter, located about 800 kilometers north-northwest of the 2005 Huygens landing site. Now, a region like this, featuring a mix of organic compounds and water ice, has got to be a compelling target to assess to see how far prebiotic chemistry may have progressed on the surface of this distant world. Titan is Saturn's largest moon. In fact, it's the second biggest moon in the solar system and larger than the planet Mercury. 5,150-kilometer wide world is 50% larger than the Earth's moon and some 80% more massive. Importantly, it's the only world in our solar system other than Earth where clouds rain liquid onto the ground, which forms streams and rivers that flow into lakes and seas. But unlike Earth's water-based hydrological cycle, the rains on Titan are made of methane and ethane. On Titan, temperatures are so cold, the water is frozen so hard it forms part of the bedrock. Titan's atmosphere is about 10 times as thick as Earth's, and it's primarily nitrogen laced with methane and ethane, a hydrocarbon soup which the early primordial Earth may also have had in its past. Scientists are now characterizing the Selk crater region to help make the 2034 landing of Dragonfly as smooth as possible. Their findings, reported in the Planetary Science Journal, describes the region as a hummocky knoll-like landscape of sand dunes and broken-up icy ground near the moon's equator. To reach their conclusions, the authors analysed radar images from the area acquired by the Cassini spacecraft during its 13-year exploration of the Saturnian system. They used radar reflectivity and angled shadows to determine the properties of the surface, looking at composition, roughness, and topography from radar backscatter. Mission scientist Leah Bonnefoy from Cornell University says Dragonfly will be the first flying machine to explore a world in the outer solar system. She says while it does rain liquid methane on Titan, it's only sometimes, and the rest of the time Titan is more dry than a desert on Earth. Place where you have dunes, some little mountains, and of course the Selk impact crater. Bonnefoy and colleagues are looking closely at the landing site, its structure, and its surface features. To do that, they're examining radar images from the Cassini-Huygens mission, looking at how the radar signal changes when viewed from different angles. The problem is the radar images of Titan through Cassini have a best resolution of only about 300 meters per pixel, and scientists have only seen less than 10% of this world's surface at that scale. That means there are probably lots of small rivers and landscape features that they simply couldn't discern. Early in the Cassini mission, back in January 2005, the spacecraft's Huygens lander descended for some 2 hours, gradually floating down into an Earth-like environment, at least in terms of appearance, and sending back pictures of streams and river valleys that were invisible in the radar images. Huygens eventually touched down on a surface best described as feeling like cold, wet sand. NASA's Dragonfly mission is slated to launch in 2027, arriving at Titan in 2034 for a 3-year stay. Unlike the tissue box-sized Ingenuity, Dragonfly will look more like a military transport helicopter. Titan's heavens, mostly nitrogen with a dash of methane, 4 times denser than the Earth's atmosphere, enables the car-sized Dragonfly to perform like a drone. It'll carry out research in chemical composition and astrobiology in order to better understand this distant world's makeup and how life on Earth may have evolved. This report from NASA TV.
Saturn's largest moon, Titan, has a thick atmosphere and a frozen surface rich in organic molecules. In 2034, a NASA mission called Dragonfly will arrive at Titan and study its chemical makeup. Dragonfly is a rotorcraft designed to visit multiple sites across the moon's varied terrain. At each new landing site on Titan's surface, Dragonfly uses a pulsed neutron generator and onboard gamma-ray sensor to detect key elements such as carbon and hydrogen in organic materials or oxygen in water ice. Dragonfly determines if there are well-defined layers of these materials just below the lander. For a closer inspection, Dragonfly uses its drill to generate tailings from Titan's hard, frozen surface. These surface samples can then be ingested through the pneumatic system, carried with Titan air into the chilled sample lines and to the sample collection carousel. One of the carousel sample cups is placed in a pneumatic port. The cup captures the surface material from the cold air stream and transfers it to the chemical laboratory for measurement. Pulses from a laser release large organic molecules from the surface sample for analysis in the mass spectrometer. The mass spectrometer sorts molecules by mass and measures diagnostic fragments that tell Dragonfly the kinds of chemical components that are present in the surface and whether there are molecules of prebiotic interest. For those potential prebiotic samples, a new cup is placed into an oven and heated to release molecules into a gas chromatograph, where they are sorted for size and type before entering the mass spectrometer. This advanced separation of organic components includes isolating molecules with the same formula but different chiral arrangements, or handedness. Having a preference for one-handedness over another is a key biosignature for life on Earth. When the chemical analysis is complete, Dragonfly may choose to take another surface sample or find a new location on Titan to investigate.
This is SpaceTime. Still to come, crunch time for NASA's Mars Perseverance rover as it continues its search for evidence of past life on the red planet Mars. And parts of the Northern Hemisphere experience a partial solar eclipse, providing people in most of Europe, Northern Africa, the Middle East and western parts of Asia with a celestial spectacular. All that and more still to come on SpaceTime. NASA's Mars Perseverance rover has started collecting rock samples from an area long considered to be a top prospect for finding signs of ancient microbial life on the red planet if it ever existed there. The 6-wheeled rover has been travelling over an ancient Martian river delta in the red planet's Jezero crater ever since July. The car-sized mobile laboratories already collected 4 samples of sediments which had washed down from further upstream billions of years ago. This now brings to 12 the total number of samples collected by Perseverance for eventual return to Earth. NASA's Associate Administrator for Science, Thomas Abuchan, says Jezero Crater was selected as the preferred landing site for Perseverance because it had the best chance of providing scientifically excellent samples. The 45-kilometre wide crater hosts a fan-shaped delta that formed about 3.5 billion years ago at the convergence of a Martian river and lake. Perseverance is currently investigating the delta's sedimentary rocks, which formed when particles of various sizes settled in the once watery environment. During its first scientific campaign, the rover explored the crater's floor, finding igneous rock which formed deep underground from magma or on the surface from volcanic activity. Perseverance project scientist Ken Fairley from Caltech in Pasadena, California, says the delta with its diverse sedimentary rocks contrasts beautifully with the igneous rocks formed from crystallization of magma discovered on the crater floor. This juxtaposition provides scientists with a rich understanding of the geological history after the crater formed. For example, Perseverance found sandstone that contains grains and rock fragments created far from Jezero crater, and a mudstone that includes intriguing organic compounds. Wildcat Ridge is the name given to a metre-wide rock that likely formed billions of years ago as mud and fine sand sediments settled in an evaporating saltwater lake. The rover abraded some of the surface of Wildcat Ridge for analysis by Sherlock. Sherlock's the scanning habitable environments with Raman and luminescence for organics and chemicals instrument. Its analysis indicates the samples feature a class of organic molecules that are spatially correlated with those of sulfate minerals. Sulfate minerals found in layers of sedimentary rock can yield significant information about the aqueous environments in which they formed. The organic molecules consist of a wide variety of compounds made primarily of carbon and usually include hydrogen and oxygen atoms. But they can also contain other elements such as nitrogen, phosphorus, and sulfur. While there are lots of chemical processes that produce these molecules that don't require life, some of these compounds nevertheless are the building blocks of life. So, the presence of these specific molecules is considered to be a potential biosignature, a substance or structure that could be evidence of past life, but which may also have been produced without the presence of life at all. Back in 2013, Perseverance's sister rover Curiosity, which is currently exploring Gale Crater in another part of Mars, found evidence of organic matter in rock powder samples, and Perseverance has also detected organics in Jezero Crater before. But unlike that previous discovery, this latest detection was made in an area where, in the distant past, sediments and salts were deposited into a lake under conditions in which life could potentially have existed. In fact, in its analysis of Wildcat Ridge, Sherlock's registered the most abundant organic detections of the mission to date. Fairley says that in the distant past, the sand, mud and salts that now make up Wildcat Ridge were deposited under conditions in which life could potentially have thrived. The fact that organic matter was found in such a sedimentary rock, known for preserving fossils of ancient life on Earth, is important. However, as capable as the instruments aboard Perseverance are, further conclusions regarding exactly what's contained in the Wildcat Ridge samples will have to wait until those samples are returned to Earth for in-depth study as part of NASA's Mars Sample Return mission with the European Space Agency. And that's unlikely to be happening for at least another 8 years. Along with its rock core samples, the rover's also collected an atmospheric sample and 2 witness tubes, all of which are stored in the rover's cache. The geological diversity of the samples already collected in the rover are now so good that mission managers are considering depositing selected sample tubes near the base of the delta in about 2 months' time. After depositing the cache, the rover will then continue exploring the delta region. This report from NASA TV.
The most detailed image ever taken on the surface of Mars, captures some of the sedimentary rocks that scientists came to the red planet to study. NASA's Perseverance Mars rover is now exploring a really important part of Jezero Crater. Around 3.5 billion years ago, a river flowed into Lake Jezero, depositing mud and sand on the crater floor, forming an ancient delta. Darker gray layered rocks make up the roughly 32-foot-tall cliff. You can see very clear horizontal layers in these rocks. Pieces of the cliff have broken off and tumbled downhill. One of the more interesting ones is the 3-foot-tall boulder called Betty's Rock, which Perseverance was able to get a closer look at. These rocks have been sitting on the surface of Mars for billions of years. And over that time, wind erosion has shaped the surface into pretty interesting forms. Immediately surrounding the rover is an area called Hogwallow Flats, previously known as the Bacon Strip, based on its appearance in orbital images. We think these are some of the finest-grained sedimentary rocks deposited in the delta. Fine-grained rocks are important because they're typically really good places to look for signs of ancient life. We'd plan to do up to 5 abrasions on the rocks in this area. That's where we use our drill to expose a fresh surface, which allows us to analyze the chemistry and mineralogy. But Mars threw us some curveballs, and these softer rocks didn't always cooperate. The rock crumbled during the abrasion, preventing us from analyzing the spot. We had 2 unlucky abrasion attempts in this area before achieving success at the Skinner Ridge outcrop. Here, we collected our first 2 rock core samples from the delta, and since then, we've collected 2 more. Perseverance drove to the delta because it is a very promising place to look for signs of ancient life. We hope to learn more when a future mission brings these samples back to Earth. So far, we're excited by what we've collected.
This is SpaceTime. Still to come, the Northern Hemisphere experiences a partial solar eclipse. India replaces Russia, launching 36 OneWeb satellites into orbit after Moscow was boycotted over its invasion of Ukraine. And later in the science report, a new study shows that cats not only know when we're talking to them, but they've probably got a good idea what we're saying as well. All that and more still to come on SpaceTime. Parts of the Northern Hemisphere have experienced a spectacular partial solar eclipse. The event on October the 25th was seen from most of Europe, Northern Africa, the Middle East, and western parts of Asia, including India, weather permitting. The best views were in Russia, where some 82% of the sun's disk was covered by the transiting moon. London and Rome managed about 15% coverage, Berlin had 32%, and Helsinki 54%. Imagine the view from the roof of Stockman's. The eclipse was the last of 2 solar eclipses, both partial, for 2022. And there'll be a lunar eclipse on November the 7th or 8th, depending where you are, as the full moon slides through the Earth's shadow. The next solar eclipse will be in Australia. That'll be on April the 20th, 2023, when people on the Exmouth Peninsula in Western Australia will be able to experience about a minute of totality, as will those in Timor and West Papua. As for our American listeners, you'll need to wait until April the 8th, 2024. That's when you're in for a real treat with a celestial spectacle as a total solar eclipse cuts a 200-kilometre wide path of totality, lasting about 4 minutes from Texas right through to Maine. Solar eclipses happen because although the moon is 400 times smaller than the sun, it's also 400 times closer, and so the two appear to be about the same size when seen from Earth. Now, normally, the moon's orbit around the Earth appears to cross the sky slightly above or below the path of the sun. But roughly every 18 months or so, the moon's orbit places it directly between the sun and the Earth during new moon, resulting in a solar eclipse. And because of that same alignment, a lunar eclipse will occur during the full moon, either 2 weeks before or 2 weeks after the solar eclipse takes place. India has replaced Russia, launching 36 OneWeb Internet satellites into orbit. The switch from the Russian Federal Space Agency Roscosmos to ISRO, the Indian Space Research Organization, follows the West's boycott of Russian products and services in the wake of the Kremlin's invasion of Ukraine. India used its biggest launch vehicle, the GSLV Mark III, for the mission, which was flown from the Satish Dhawan Space Center in Sriharikota on the Bay of Bengal coast. This latest mission means OneWeb now have 462 satellites flying. That's more than 70% of what the company says it needs in order to provide a global broadband service. Overall, OneWeb's planning a constellation of 648 of its 150-kilogram Ku-band satellites, which will be placed into 12 near-polar orbits at an altitude of 1,200 kilometers. With Russia now out of the game, OneWeb are planning at least 1 more launch with India and 3 with SpaceX in order to get their constellation finished. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.